Hello everyone, how are you? Doing good? I'm Lynn Langit and this is Serverless SQL. Last session of the day, so I gotta keep it interesting or you're gonna go get those beers, I know it. So SQL, the ultimate domain-specific language, 45 years old. Oops. So if you're like me, the way that you got introduced to SQL, .NET Conference, basically a lot of Microsoft users here, was Microsoft SQL Server. So even though we're going to do Serverless SQL, I thought I'd start with something that I think is kind of interesting, and it does have bearing on what's happening with the world of SQL. So I'm going to show you some SQL. So this looks pretty ordinary. You're probably going, gee, why did I come to this session? This looks just kind of like SQL Server we know and love. Well, it kind of is, and it kind of isn't. You might notice that I'm on a Mac. And of course, just to show you that I'm not doing any trickery here, it runs a query, explains a query. Super cool. If you've never seen this tool, it's SQL Ops. It's a cool little tool. What's interesting about this, and really kind of sets the tone for what we're going to talk about, is where this SQL Server is running and how this SQL Server is running. It's running on Docker. So this SQL Server instance is running on Linux, on Docker, on a Mac. And I always like to start with this in this talk, particularly when I have a Microsoft audience, because the game for SQL, whether it's Microsoft SQL or somebody else's SQL, has really changed in the time I've worked with it. And that change is informing how I, as a cloud data architect, design for my users. And we're going to talk about that. So because SQL is so pervasive, there have been many, many flavors and forms of SQL. There was a really great talk at this conference on Microsoft Data Lakes with a flavor of SQL called USQL. Because I knew that would be very well covered here, I'm distinctly not covering that, but I do recommend that as an ancillary to what I'm talking about, because the design patterns and the implementations that I'm talking about on the Microsoft stack were really very fully covered in the Data Lake talk, so I recommend that you watch that. So this is a serverless SQL talk. So I like to always think about costs, cost benefit. So if you had $50 US, what could you do with SQL? What do you think you could do with SQL? I bet you would be surprised to know that you could do this. Actually, this is less than $50. In 22 seconds, you can process nearly 5 terabytes of data using ANSI SQL syntax, managing 0 servers, doing a query that starts with 84 million rows and aggregates to 2,500 in less than 30 seconds for $25. That's why you're here. That's the promise of serverless SQL. No servers. So what is this? What is this mystery thing? Well, I got to show some SQL. This SQL, this implementation is a Google implementation. So here is that actual query, and I recorded the demos because I can more easily talk. So the domain that I'm working in a lot these days is huge, huge data, bioinformatics, genomics. Have you guys heard about CRISPR-Cas9 and genomic editing? I'm working with bioinformatics teams worldwide and trying to help them to process data that comes in from the sequencers and process it using, among different methods, SQL. This is a very gnarly, long, complicated, nested selects, joins, group bys, order bys, so on and so forth. There's no servers. You simply upload the data, write the query, and here you can see the query is running, or the recording of it is running. And this will take 30 seconds. You're charged by the amount of data scanned. There is a charge for storage, but it's so nominal it's almost inconsequential. You're charged by the amount of data scanned. And so once this finishes, then, as we have known for so many years with our on-premise database and server solutions, you can look into how this query was executed in case you want to optimize your SQL statement. So you can see there's the timeline on the bottom, and when I scroll down here, you can actually see the execution plan, assuming that everybody in here has experience with on-premise SQL database server systems, whether it's Oracle, SQL Server, or whatever. You can see on the very bottom you have the execution plan. So this product or service is called BigQuery. This is Google BigQuery, and it was the first implementation of Serverless SQL. And rather surprisingly, it's not new. It's been around for many, many years. It was introduced in 2011. It's a full implementation of Serverless SQL. Works with text files. You query it with ANSI SQL. There's also a ton of public data sets that are already available on the Google Cloud, and you pay by the query execution. Initially, there weren't cost control metrics associated with this, and that was a big problem in adoption. But a couple of years in, Google added cost alerts and quotas. As the product has matured, it has become capable of serving different types of workloads. So you can now have table partitioning, you can do streaming, you can actually do updates with DML, you can create UDFs, you can connect with JDBC, ODBC. It has now IAM-based granular security, and it integrates with Google Cloud Platform. So the question really is, why didn't more people notice? Why was this product that's so innovative so slowly adopted? Why has it taken so many years for competitors to create competitive products that are serverless SQL? And I think it's because it's the pipeline. When Google released BigQuery, they released that section of their pipelining tools. And it did have applicability for many of my customers, startups in particular. Although I would introduce it to enterprises, to what I call party on the data, especially marketing data. But what I found is that for broader adoption through my customer base, there were missing pieces of the pipeline. How did you get the data up there? How did you validate the data? How did you transform the data? How did you view the data? So on and so forth. So of course, where I live, and you can tell by my accent, I'm not Australian, I'm from America. The leading cloud provider in my market, which is California, is Amazon. So interestingly, Amazon started to pay attention to this, and they started to take kind of a different approach. And this approach I see now as a pattern in the cloud industry. For those of you who don't know, I'm an independent cloud architect. I've been independent for 7 years. And I work with all the different cloud vendors. I do work with mostly Amazon, but Google. I've done some work with IBM, some work with Azure, and even now some work with Alibaba. So I like to say I work for my customers rather than a particular vendor. Previous life, I did work for Microsoft for 5 years. So I'm very versed in that ecosystem. So this is a pattern that I see coming into the serverless SQL world. This is the data lake on the bottom, which is your object store, and then a series of services in the middle. And how these services are offered up is really interesting to me because there's different approaches from the different vendors. And one of the things that I try to do as a cloud architect is help my customers to figure out which ones are going to be right for them. But sort of generally, the blue box, there's some service or mechanism for ANSI SQL exploratory queries. And we saw that with BigQuery. You can write a query and explore the data. There's some mechanism for bulk transform through Hadoop or Spark. And you might say, well, that's not SQL. Well, there is a flavor of Spark that is Spark SQL. And then in some vendors, there's some mechanism for warehouse style or aggregate queries. Notice there's a line directly from the data lake up to the visualization client as well. And importantly, there is a visualization client. So in thinking about this broader ecosystem, how do the vendors address this? And in particular, how did Amazon address this? Because Amazon, again, I don't know the Australian market as well, but in where I am, it's 75% of my customers are in the Amazon ecosystem, so I have to pay attention to that. If you don't know, that's the CTO, Werner Vogels. So they took a different approach. They said, we really want to provide customers with parts and pieces, and we want to give them choice because there's different functionality. So one of the services that they came out with is something called S3 Select. So the idea of it is that you put your data in the data lake because it's cheaper from a storage standpoint and easier. Just put your text files. And then you might want to take like a peek or a look at them. So let me show you what that looks like. And again, I recorded a demo here. So the idea is that you've just put your data up into S3, and you haven't defined a schema or anything. And you just want to look in that bucket, but you want to use the syntax you know, which is SQL. So here I have some CSV data, and you notice if I click the More menu and I say Select From, you notice on the left side this supports CSV or JSON data, and you specify the type of delimiter, comma, tab, or custom. And you can click and get a file preview without defining any schema. It's inferred. So that alone can be useful. Now, in addition to that, S3 supports a subset, not full ANSI SQL, but a subset. So here I'm doing a SQL query, and I'm getting a result. So how I find this to be useful is when I'm working with a lot of different types of CSV files and just quickly throwing them into the data lake. It's a quick way of validating what's there. So it's an interesting service that is relatively unique, I think, to Amazon. It's different from BigQuery in that BigQuery you need to typically upload to BigQuery rather than uploading to Google Cloud Storage, although there is some bridge to that now. All right, so you store it in S3, CSV or JSON, you select from. Files can be encrypted, they can be compressed, they can have headers. It's a small look. In the console, you can use up to 40 megs from files up to 128, and it's a subset of SQL expressions. The next sort of product level up in terms of serverless SQL in the Amazon ecosystem is really in some ways kind of a direct competitor to BigQuery. This was really interesting. I was at reInvent, the big Amazon conference 2 years ago, and this was so secret. I'm an Amazon partner, kind of like an MVP for Microsoft, but for Amazon. So generally, I get the information that's going to be released at reInvent early, but this was such an important thing for Amazon that they didn't tell anyone. And literally, they released the product at reInvent because they knew that it would be very interesting for the market. So this looks and feels very much like BigQuery. The difference is this runs against data in S3. So you upload data to S3, then you define a schema. So remember, in the previous tool, we did not have to define a schema, it was inferred. And then you run a SQL query against it. With Athena, you get full ANSI SQL. The pricing and the speed is really close to what BigQuery is. The pricing is about identical. So how does this look? So Athena looks like this. So you have first a Hive-like syntax, if you're familiar with Hive, or DDL, create table, basically. So then you define a schema over your CSV file. And then once you've defined that schema, and I'll be showing how the schema is run here. It's a create external table, basically. And notice it's got an underlying connection to Hadoop because it's using those libraries. And it's using Parquet, which is a columnar format, more optimized for scans, basically. And then when you preview the table, you're running a SQL query. Now this query is really tiny. The big query that I ran previously had a huge amount of data, just to kind of prove a point. This literally ran in half a second, it's only 49 megs. But from a look and feel. Now of course I'm running these things in the console because it's easier to consume them when you're trying to learn a lot of new services. Just like any other cloud service, you can run this from the command line interface or from the SDK. It's programmatically how you would run it in production. And here you can see, very similar to the BigQuery interface, You run the query, you see the results, and you can then work with the results. Interesting, there's a history tab here, so you can actually see from and you can export this as a log file, so you can see from a cost standpoint. It was interesting, when I first worked with BigQuery, one of the objections was, when I taught it to the analysts, because there weren't cost controls, they actually loved it so much, they would spend too much money. And so the managers would take it away, because it was so easy. They would just upload all their data and just query, 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 query. So cost controls are really important with serverless SQL, because once people see it, they really like it. So you store it in S3. With BigQuery, you have to actually import it into the BigQuery storage. That's the difference. You define a table schema, you run a query. Now, Amazon has told me, please, please tell people this. If you have small amounts of data, you're being charged by the size of the scan, so you just put it up there. But if you're using production size data, you want to compress it, partition it, and convert it to Parquet, because you can save 30 to 90%. And I have an actual example coming up. So the underlying technology is Presto. It's a serverless and auto-scaling. It supports all the cool SQL stuff we know, joins, windowing, and arrays, bunch of data types or file types, CSV, JSON, ORC, Avro, Parquet, CloudTrail, actually, too. It's supported by JDBC, so you have connections with other Amazon relational database services. And you can visualize with QuickSight, which is their Power BI kind of service. Secured via their full permission store. It doesn't have UDFs or stored procs yet. BigQuery does. It supports compression, and the query results are streamed to the console and stored in S3. And here's a cost example. Basically, it's probably too hard to read, but if you compress it and convert it to Parquet, it reduces from $15 for 3 terabytes to $1. So it matters when you're doing really big data. So interestingly, Google and Amazon really differ in the way they release products. What Google does is they basically say, okay, we're going to take a product that we use to run our own infrastructure, like BigQuery, and we're just going to make it available. Amazon says, what do customers want? What do customers need? What do they have right now? So if you don't know, the relational database service Aurora, which is the managed MySQL, is the fastest growing product in the history of Amazon. Because even though we're in a serverless SQL talk, a lot of us still are really comfortable with server clusters. And so the lift and shift of just moving up your existing server cluster, and you could, RDS also supports SQL Server, so you could move SQL Server, or you could move SQL Server into MySQL or whatever. That's a really common path for people. Well, I think this was actually pressure from Microsoft, because I know that Microsoft did some stuff with SQL Azure in terms of elasticity. And so Amazon, this is 2 months old, recently released Aurora Serverless. And the idea is that you have additional capacity. You have this warm pool of databases. I think it's very much like what I understand the Microsoft implementation to be. But it is, to me, it's kind of a misnomer, because you still have the core of the Aurora servers. You just buy in capacity units is kind of the difference. So why you might use this versus using the previous service is because you have an existing application that you don't want to rewrite. You do just want to move up, and you want elastic capacity. So the idea of this is variable workloads, that you have the serverless component, so that you have burstable workloads, because you can set the min-max, and you purchase Aurora capacity units. And I apologize, I do not know whether this is available in Australia yet. You should check, because I know how it is. I know. They come first to the US and then the rest of the world, because this is only a month old. Okay, so that's on the relational side. The second fastest growing product in the history of the Amazon ecosystem is Redshift. Redshift is the data warehouse replacement. And this is a territory I know really, really well, because when I worked at Microsoft and when I started my consultancy, I was very much in the old stack of, and I think I can see in the audience, people are close to my age, where we had OLAP and OLTP, and we had SSIS and SSAS and all that. And some of you might know I wrote 3 books about that technology. So that whole data warehousing world was my world. So when I left Microsoft and became independent, I did a whole lot of Redshift conversions because Redshift was cheaper, basically. So it's a data warehouse. It's designed for aggregate queries. And up until Aurora, it was the fastest growing product in the history of Amazon. And they were just basically sucking data in from Oracle and from Microsoft and making these little mini data warehouses. I could set up a data mart in a couple weeks for a few $1,000s. So as they did with the relational store, RDS, Amazon has taken the idea of elasticity and applied it to Redshift. So how it works here is you have a core Redshift cluster, and then I like to think of this in terms of use case around archival data. Maybe you move your archival data out of Redshift into S3 because it's much cheaper, and then you have Redshift capacity for those history queries. It's like a type of a use case. So it's elastic to be able to query across S3. So Parquet again, text file, sequence, RC. You can have compression. Encryption is server-side only. You do really want to partition. And you're going to use schema against the S3 files, Athena, Hive, or external. So lots of new words, lots of terms. So in the Amazon ecosystem, you have Athena, which is the quick look at S3. The quick look. You just right-click in S3. You have Aurora, and that is the relational database that can be now elastic. And you have Redshift, which is your warehouse, that can also be elastic. So again, don't shoot the messenger. This is just the landscape out there. So in addition to that, you have to figure out how to get data into these services, because remember I said it was a pipeline? So how do you get data in? How do you validate it? What's the ETL, extract, transform, and load, or ELT, right? So yet another new service. So that service in Amazon is called Glue. So Glue has two parts to it. It has a transform, a scalable transform part, so a serverless SQL for transforms, but it also has catalog. You know, I was talking in some of these services how you have to define your schema over the table. So think about it. You're going to do relational queries on your data in S3. You're going to do warehousing queries, which are basically aggregates, on your data in S3. Wouldn't it be smart if you had like a one place for that schema so you don't have to define it all in all these services? Well, that one place is Glue. So Glue, that's why it's called Glue, right? It has two things. It has the schema, and it has the scalable transformation. Now, a cool thing about Glue is, depending on the complexity of your file, it can not only infer the schema, but it can update. So think about this. I had a financial services client in New York, and they were pulling all these feeds in, right? And so they had like a team of people that had to like look at these feeds and update their manual scraper code or processor code every time the schema of the feeds changed. I know this is a common use case. It just happened to have it in financial. They switched to Glue, and they could re-provision those people because the feed schemas were automatically updated and stored. Can you see that? It's really kind of a cool use of this. All right, so let's show you what this looks like. So again, there's two parts to this. The first part is the metadata, and the second part is the transform. This one's a bit longer, but not that long. So you can see the data catalog, and we have some tables. So you basically point the crawlers to S3 buckets, and you make connections to it. And then you can either, with a good old text file, define the schema, and there we're pointing. And you can also make connections, and you can make connections to a number of things. So look, Redshift, RDS. Once you have this schema, you can connect across all these services. And then you have the crawler, and you notice you can set the crawler to recrawl what's in the bucket. That's how you get the dynamic schema update. And you can do fancy things like excluding patterns. And notice you can crawl out to JDBC as well, which is kind of cool. And then you can also add classifiers if you want to define your own schema. So the grok pattern, which is like a regex, or XML or JSON. Then you get into the ETL. So the ETL, if you're familiar with this, again, I'm thinking a lot of Microsoft people here. It's kind of like looks like an SSIS when we get down there, and I'm going to actually skip up and get down there and go into the script here. So there. So it starts looking like an SSIS, where you see the transforms on the left side. The difference is this is PySpark, which does have a SQL flavor to it, but it is PySpark. So it's Spark, which is Hadoop in memory, which is a totally different technology for processing or transforming. But again, the idea is that you will use a distributed Spark client to do your conversion to Parquet, for example, or your validation against your metadata. And you can see the different transforms here. So that shows a transform. And then another aspect of the system, another type of SQL, is when you're streaming data in. I've been talking about batching it in, is Kinesis. And that's their streaming product. It's like Kafka, not as sophisticated. Kafka is the open source version, or PubSub for Google. But they do have an analytics piece to it, and that has a SQL wrapper on top of it. So the commonality across all these products is in the Amazon ecosystem, they're putting SQL-style wrappers no matter what you're doing, which I think really adds to the usability. The problem is figuring out the Amazon ecosystem which product to use, because they have so many. So talking about that, if you take that general pattern that is occurring in the industry around serving data up in a more distributed, scalable fashion, this is what it looks like in the Amazon ecosystem. At the bottom, for the data lake, you have S3. In the middle, the blue box is the sort of quick look or hot or relational queries. You have S3 Select, and I think I might have not said that exactly correctly previously. S3 Select is where you right-click in S3. You have Athena, which is the BigQuery like, where you have defined schema and you have a full ANSI SQL syntax. And then you have Aurora Serverless, which is the expandable relational database. And of course, that has regular SQL syntax. So you have a spectrum of choice. I don't know if this is the right answer. I'll tell you, I do use these things though. I use S3 Select because it's easy. You just right click, boop, do SQL. I use Athena when I get text files because you just upload them and doop, and then they're in the Amazon ecosystem. In the middle, they have, for the transformation, Glue and the metadata catalog. And then to the right, they have Redshift Spectrum for the warehouse. And they have a product that will visualize any of this stuff called QuickSight. So what am I using this for? Basically everything. In terms of a product with a pure relational database or pipeline, I've not built one in the last 5 years. I've always built some variety. Now, up until relatively recently, even if I built on the Amazon ecosystem, I usually still had some BigQuery in there because of that flexibility of that product, that Athena-like flexibility. But now that I have Athena, it's going to be interesting as I work with my customers to see if I stay on one vendor. So you can explore and experiment. You can do ad hoc reporting. You can data warehousing. You can do data processing. Can you get rid of your servers, right? That's the question we're here to really think about. And of course, it depends, right? So the pipeline pattern for AWS, the way I work with it now, is you have two sections. You have an ingest and prepare, and you have a query and present. Of course, you have IAM roles because you have security. So in the ingest and prepare, first you have an extraction. You get some data, and then maybe you do an Athena or an S3 look at that. Then you might do some conversion with Glue. Then you have process data, and then you'll do maybe some verification with Athena, maybe some more conversion with Glue. Then you'll move it over into the query and present. So I think of this as processing, quick look, getting an idea of the value of the data before you move it into the more expensive persistent data stores. I think in the Amazon ecosystem, I'm still going to be using servers for a while. I do, because I have a lot of customers on RDS and Redshift. So I don't really see that going away. I do think it was very smart on the part of Amazon to do this elasticity, because that allows customers to, for example, like I was talking about Redshift, archive off their data when the Redshift cluster gets too big into S3 and use Redshift Spectrum for those historic queries that don't happen as frequently. You'll notice in visualization I have QuickSight and then I have Jupyter Notebooks. And there's a specific reason for that we'll get to as we go through this. So now we're back to Google, and the picture looks very different. Now, when you're in my talk, you get my opinion, and there's not very many Google people, Google Cloud people here, but that I've talked to. But if I had somebody who worked at Google, they would probably really disagree with me about this, because they do have some more services, but I'm the intermediary between the vendor and the customer, and these are the services that I think are the most useful. So if you notice up here, basically I have three things. I have the data lake, I have something called Data Studio, which is their version of Power BI, and I have BigQuery. I have BigQuery for ANSI SQL, for ETL, for warehouse, and for storage, which is actually what I do. And it's sort of an interesting pattern. It has pluses and minuses. Obviously, when you're working with one product, you're not going to have as much flexibility in terms of features and functionality as when you work with multiple products, but you're going to have a lot less complexity. So who is the customer that I work with on this? Startups. I work with startups in this pattern very, very frequently. I live near Los Angeles, and so there's a lot of new media startups. I call them the useless, Snapchat remonetizers and all that kind of stuff. But hey, they have a lot of venture money, and they need someone to build their stuff. So I've actually gone in and had people that were doing various kind of NoSQL implementations or a bunch of services from a different vendor, and just said, just put everything on BigQuery. And actually had some good success with that. What I think is interesting about this, and I applaud you guys for coming out to this talk at the end of the day, and hopefully you take this away, is that we have choice. So to me, Amazon offers this greater variety that probably is going to service my enterprise customers and my mature startups more fully, probably. And BigQuery gives this agility that I can really get. When I'm talking big data sets, I'm talking the entire data set of YouTube. I'm talking big, like we had to call Google. Now, of course, this is a Google service, so that kind of makes it easy, but you can really put a lot of stuff on BigQuery, a real lot of stuff. So Google's version of this has ingest, and so they have what they call the cold path, the batch path, cloud storage, and the hot path, PubSub, which is their Kinesis or Kafka. And then they have this piece in the middle that I wish would become more mature. This is their version of Glue. It's called data flow. It can work really well, but it requires a lot of developer expertise. You'll be writing a lot of code. It is very powerful, but I just don't think it is as usable for the majority of my customers. So I tend to prefer to actually write my transforms in BigQuery. So then BigQuery, and then they have Cloud Data Lab, which is an alternative to their visualizer. This is hosted Jupyter Notebooks. But you can see their architecture is much, much simpler. This is their reference architecture, one of them anyway. So if you didn't get what I just said, there's a slide to summarize it if you're kind of zoned out at the end of the day. Hey, I didn't put like a math graph, and I'm not talking about derivatives, and I could. Just joking. I've never had so much math in a conference, which I actually frankly enjoy, but it does make me tired. But yeah, so this is the way I see the world, and I just think it's fascinating. It's a great time to be a consultant here because I feel sorry for my customers. They're really confused, and they really need a guide because these different approaches the vendors are taking. So just when you thought we had like kind of enough to actually build a pipeline, speaking of all that math and all those derivatives, all my customers are using machine learning now. So this is the way I draw a pipeline. This is the Lynn pipeline. You can see this is the batch path, this is the hot path. So you got files and going into buckets or data lake. You got events that are streaming in. And then you have some sort of metadata transform and clean. Then you have SQL, basic SQL queries, which you can do with BigQuery or you can do with Athena or whatever. And then you have enriched files. And then you can go straight to visualize, and that might work for you. But the majority of my customers really benefit from some machine learning now. And they will often use Jupyter notebooks. So what is that doing to our serverless SQL story? What's interesting about this is that that's why I'm in Australia, other than your coffee and your whiskey and all the wonderful things I love about, and your Tim Tams. But I'm actually in Australia, and I'm the American at the conference who's not jet lagged, because I've been here for 2.5 weeks already. I'm going to be here for 6 weeks this time, because I'm working with CSIRO. So I'm sure all you Australians know CSIRO. If you're not Australian, it's the Commonwealth for Scientific, Industrial, and Research Organization, and I'm working with the bioinformatics team. Been working with them for a while. And so they have a very challenging data problem that we're working on, and they've built a custom machine learning library. It's called Variant Spark. And this is sort of the state of things right now. So what we've been doing is we've been working together, and this is not SQL, this is the non-SQL part of the pipeline. So this is the data lake over here, and this is Spark and their library, and this is a Kubernetes cluster. So I'm literally going up to North Ryde, and I'm spinning up the cluster, and I'm putting in the genomic data, and I'm saying, wow, that's a lot of data. We need to get a bigger cluster. That's what I'm doing. That's what I'm doing. But in addition to that, once we get a big enough cluster, we need to do what? It's the pipeline, right? That's how I started this talk. It's the pipeline, and there's a SQL role in this. So what is that pipeline? What does that look like? Well, I redrew it for you guys this morning because I had a really scribbly drawing, and I was like, yeah, I can't show them that. So this is my new fresh drawing. This is as good as I make it. So we basically have those phases, and we're not doing streams, not yet. So this is the data coming in. So we have VCF, we have FASTA, we have FASTQ, we have all kinds of different genomic data coming off the sequencers. And then we need to write some sort of business logic to examine the data, to figure out how to work with the data. And I think this will be Lambda-driven logic, because that's kind of the modern way to do things. Then we need to have our magic expando cluster that is the right size. And then we need to visualize and work with the data. It's interesting, when I was working with a bioinformatics researcher, guess which pervasive tool they were using to do their final analysis? I know you know. What was it? Excel. That's right. It's always Excel. It's always Excel. So if you can move people up from Excel to SQL, you're doing great. So that's my goal. So in any case, this pipeline, I'm hoping, seriously, we can move up from Excel to some SQL queries to examine some of the data for quality before they run it into the cluster. That is sort of my goal. So how do we integrate this? How could we do it? I said in the beginning of my talk that SQL is the ultimate domain-specific language, because as much as people have wanted it to go away, it just doesn't go away, and it keeps getting bigger, and everybody learns SQL, and it's just still out there, right? So what's just fascinating to me is whether you like them or whether you don't like them, you do have to pay attention to what they're doing at Google. You just really do, because these people know how to work with large amounts of data, and they know how to be practical about it. And one thing they really know is machine learning. So what they have introduced this year is a set of extensions in BigQuery, which, remember, is ANSI SQL compliant, that allow you to do guess what to your data? Machine learning in SQL. No joke. I'll show it to you. Again, I think it's so forward-looking that a lot of customers can't kind of even understand what you would use this for or why you would use this, because their statisticians are still telling them, you know, you got to use R, you've got to use whatever, right? But this is it's called a Colab. It's a version of a Jupyter notebook. This is connecting to BigQuery, and it's here. I'll just start running it. And it takes the full life cycle that I talked about, and this could be applicable potentially to domains as big as genomics. And it allows you to first, after you authenticate to your GCP account, it allows you to, in your notebook, analyze your data. So I'm analyzing my data, and you can see I have, if I can see this, it's some huge amount of data, 114 million rows, yeah, like that. So think of, I'm the end user. It doesn't fit in my Excel spreadsheet, but I can use my Jupyter notebook and see how big it is. I'm very happy. I'm not kidding you guys. Jupyter notebooks are sort of the new place that we're going here. Here they can use Pandas, which is a data science visualization library, and so they can examine and explore the data. That's that sort of am I going to process this data? There I'm describing the data, and I'm using libraries that I'm comfortable with, because if you're not familiar, Jupyter notebooks I call them the new terminal, basically, because you can document, run, and visualize multiple languages in the same environment. I personally use them all the time. I recommend that you do too. They're wonderful. So you can see now I'm going to create a machine learning model. So this is in BigQuery. So you can see that this is a logistic regression model. And it's just SQL, create or replace model with options, model type logistic regression. That's cool. That's really cool. And then you can see the model information here, the model statistics. You might remember if you've gone to some of the machine learning talks or you're using machine learning, those are epochs, training epochs or epochs, or however you pronounce that. There's the logistic regression. But think about this. This is being run on the data that is stored in the data lake. So you can do SQL queries, you can do machine learning, you can do data modification. This is kind of the dream, isn't it? All in the same place. Kind of a nightmare too, because you're like, gosh, I'm going to give all my data to these people? I'm not really sure. I understand that. But again, don't shoot the messenger. Here we're evaluating the model. So we're looking at the quality of the model. And you can see that the area under the curve is 0.98, so it's a pretty good model. So the ROC. And then we're going to use the model. So we're going to call predict. Now, Google isn't the first vendor to think of making a familiar language for running machine learning. I think that's actually quite smart. Now, just as an aside, I have a background in linguistics, and I learned how to program when I was in the middle of my career. So I always kind of favor DSLs or language interpretations that make languages more usable. But I think that's just kind of practical. Because aren't we all kind of struggling with machine learning and the applicability of it? I know I am. I'm spending an inordinate amount of time trying to really learn TensorFlow and really learn, some of the libraries out there. And if I can just use SQL, I'm probably going to do that, So anyway, I showed SQL. If you want to take a picture, this is what you want to take a picture of. The most important thing is the orange box on the right. This is where I see the vendor services going. I do see servers going away. It's a question of when. And then, what is the transition if you're in servers right now? And which services are you going to select for the middle piece? Are you going to select the different services, for example, that Amazon has, and which ones? Or are you going to restrict them? I mean, that's another thing to think about. If knowing that you can have users that can right-click in S3 and do queries, do you want to turn that off, right? Because you might want to for some cases, or log that. Figuring out how you're going to do those middle pieces. And I think the machine learning is really, really important. And I do think Google has got out there first. So irregardless or not, if you're on the Google ecosystem, I know I'm going to be really drilling in and looking what they're doing. Because what's cool about cloud right now is it is such a gold rush that when one vendor does something interesting, the other vendors do come along. And it is good for us as customers. Good for us in that we have choice, bad for us that we can never rest because there's always something new. But I do think that this is a way that more of my customers are going to get actual business value out of machine learning. I mean, again, I'll be the one to say it, right? Machine learning can provide tremendous value, but it also can be a ridiculous waste of money and time. I did a little survey last year, and I said, how many people have, of my friends, my nerd friends, how many people have a TensorFlow model in production? And it was like less than 10%. Like, okay, people don't say that, right? They like, oh, partial derivation is easy and da-da-da-da. Okay, it's not easy. It's really, and I know how to do it. It is not easy. And it's really not easy to explain it to people who do not know how to do it, which ultimately you have to do. So you need to use the right tool for the job. And guess what? SQL's been around for, what did I say, 45 plus years. People know how to use it. So to me, that's the sort of the big takeaway. There's two parts of this. One is that we are moving towards the data lake pattern. You should at least investigate it, especially for new workloads. Vendors are giving us a lot of choices. Two, the more SQL you can use, I think the faster you're going to get to business value. And if you want to learn more, I am working on something for Google. It's not done yet. Watch my Twitter if you want to see it. But the Amazon piece that I have is a takeaway. And I do lots of courses for various vendors. You can watch my courses or whatever their subscription, but this is free. This is a GitHub repository that actually I made for myself. But I find that a lot of people are really liking it. So the idea is if you want to try out all these services and you just don't want to read all the documentation and waste time, it's a one-stop shop. It's a hello S3, Select, hello Athena, hello Redshift Spectrum. So it's all the scripts, all the setup. It's just simple. You can just go there and say, okay, I want to try this out. Okay? Because in the various courses I was doing, I was like, God, I can't find this. And it's taking me forever. And this database doesn't load properly. So it has sample data that actually works, right? So hopefully this will make it worthwhile that you hung in there with me on this last one before beers. Because this is, seriously, I use it myself. And I'm working on one of these for Google, too. So that you, who has notoriously horrible documentation. Google, if you're watching this, fix your damn documentation. I'm serious. I was working on the BigQuery machine learning, and there was missing a bunch of stuff. So I provide this as a public service, right? And for myself, my customers, and for all of you. So really do try this out, and it's GitHub. So if there's some mistake or problem, do a PR on it, and let's just all make it better. And that is my story of serverless SQL services, and I think I am done a bit early. So how cool is that? So yeah, that's all I have to say. Question?
Yeah, so with regard to the serverless, a lot of the customers that I've been working with recently are not sold on serverless, especially when it's software as a service.
Mm-hmm. So the question was, companies are distrusting serverless, and I really think that's why Amazon took the elastic approach. Do you know what I mean? So you can say to the company, let's just take the example of Redshift. So you have this big data warehouse, and you're spending too much money on your data warehouse. So they kind of gave you the easy path of, you can just archive your old data off, and you're really kind of moving into serverless. Whereas with Google, it's no, put everything up into BigQuery and trust us, right? And you do get objections of people I'm not doing that. I don't want to do that. So there is a political aspect, a people aspect to it. You also, frankly, get with DBAs, and I can really relate because I kind of was a DBA. They're kind of freaked out. What do you mean? I can't use my tools to control my server. I don't want that. I'm not getting that, okay? And for some of my customers, that doesn't make sense. So it's a mix and match kind of thing. So how do I get them to trust? I usually get some data that is more optional. A lot of times it's marketing data or something they just sort of want to look at and have them just try it out. So, and then it's a blended strategy. Does that make sense? Yeah? Okay. Anything else? I'm going to be hanging around at the party, so we should be drinking. Yeah, let's go drinking. Okay, thanks for hanging out, guys.